So you and a friend are enjoying exercising together, and one day you're about to go running, then your friend receives a phone call, and you decide to start running. So this is you already going. Boop, 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 boop. All right, so notice it's the time. After 4 minutes, you are half a mile away. After 8 minutes, you are 1 mile away, etc. So the red line represents you, and the blue line represents your friend. So at 5 minutes, they're at 0. But at 12 minutes, they're here at 3/4 of a mile. Okay, so will your friend ever catch up? All right, excellent. So if we look at this, we can say that these two lines are parallel, so therefore they never intersect. What's that mean? That means that my friend and I will never be at the same place at the same time, or the same distance from the house, assuming we're going in the same, on the same route. So will they catch up? And the answer is no. And how do we know that? Because the slopes are the same. So besides saying slopes are the same, what else do we know? The lines are what? Go ahead. Parallel. They are parallel. Good. So since the lines are parallel, we know that the lines will never intersect, and slopes are the same. So what I would like you and your partner to do is spend a few minutes and find the slope, and notice up here the terms they use. They say M1 and M2. M1 equals and M2 equals. And the same thing here, M1 and M2. Now, you probably already know that slopes of parallel lines are what? You probably already know that. But down here, what about the perpendicular lines? So especially work through that. So take a moment to find the slopes here and see if you can make a conclusion about how slopes are related. Go. Slope. What'd you get for the first slope there on what looks like the parallel lines there? All right, good. So 1/4 for that one. And how about the other one? Good, and the other one is also 1/4. Again, do note that please change that R right there to of parallel lines. So if we had to make a conclusion, class, what would you say? The slopes of parallel lines are? The same. Woo, woo, yay. So whenever we have a coordinate system and we want to see if the lines are parallel, all we have to do is calculate their slopes, see if they match. Now, how about perpendicular lines here? So we know they're perpendicular because they tell us, so we could have even put that mark there. And now, what about these two slopes? The slope 1 is the one that looks a little more horizontal, and the slope 2 is the one that looks more vertical. What'd you get for the first slope, please? So -1/6. And how about for the second one there? Simply 6 right there. 6/1 works, but we do simplify generally the slope to be 6/6. Now, if it's helpful for you to see the -1/6 and the positive 6/1, just so you can compare, that is fine, but the actual answer would be the slope is 6. So the slope of perpendicular lines are, and how would you say it? There we go. Not even like, it's exactly opposite reciprocals. So that's one way to say it. They are opposite reciprocals. Another way to say it would be that the slopes multiply to -1. Here's another way to say it, is M1 times M2 is equal to -1. That's the other way of saying it. But opposite reciprocals is how they relate to each other. And this one over here is how they relate to -1. Okay. So take a few moments here to determine 1, 2, and 3, which lines are parallel, perpendicular, or neither. So calculate the slopes and then make a conclusion. Ready, set, go. The next thing we want to be able to do is write equations of lines that are parallel or perpendicular to a given line. Whether the given line is drawn, whether the given line is just information, or whether we actually have the function itself. So what is the equation of the line that passes through the point -2, 4, and it's A, parallel, and B, perpendicular? So we're going to do two separate problems, one being parallel and one being perpendicular. So what we have to do is extract data from this. This is the original line. So I look at my original slope. My original slope is 1/5. So if I am finding the parallel line from 1/5, what is my slope going to be? What is my slope going to be? Well, it's also 1/5. Great. Now let's just change gears a little bit. What if I was doing perpendicular? Please. So we take the opposite reciprocal, so simply -5 there. And now what do? We are told, well, let me show you something else. Notice that we can completely disregard this. It doesn't matter through what it passes over here, because we don't care about this b. The only thing we want right here is the slope, because slopes of parallel lines are the same, and slopes of perpendicular lines are opposite reciprocal. So we're only extracting one piece of information. The rest we can toss. So now what are we going to do? We're going to substitute the point they gave us and the slope that we thought about. The slope that we derived and the point they give me, and we're going to put that into point-slope form. So let's recollect what point-slope form is. You should always write it down when you use it, because practice makes permanent. And this is point-slope form. After we substitute in accordingly, so here's my y, here's my x, and here's my slope, and I put it in here. Notice you can skip this step right here of substituting. If you just want to jump straight to the simplify part, that's fine. And here would be the official answer that you can leave this in. You do not have to distribute. You do not have to get y by itself. This is point-slope form, and it is one possible answer. And it's the simplest one to do, just because it's just the one step, substitute and simplify. If you did choose to put it into slope-intercept form, then you would have to get y by itself and keep going. But for the most part, it's not going to ask you to do that necessarily. The thing we have to do if we're looking for the perpendicular is simply change the slope. So notice that I can do exactly here, and all I have to do is change that to a -5 and say x plus 2. So notice the pre-work I don't have to do. However, that only works when it's in this form. I'm going to go ahead and put this into slope-intercept form just to show you that although the slopes are the only change at this step, turns out your b's are probably different also. All right, so I'm going to distribute there to get -5x minus 10. And I'm going to isolate the y to get -5x minus 6. So this is one answer, and that would be point-slope form, slope-intercept form if they asked for it. Mint slope-intercept form. So how do I slope-intercept form this one? All right, so we do have to get y by itself, so I'm just going to distribute this way. So I get y minus 4 equals, now this gives me a fraction here, 1/5 plus 2/5, like this. Now I have to add the 4 to all sides. Sorry that I'm running out of room here. Add 4, and remember, adding 4 is the same as adding 20/5, right? Because I'm putting it into common denominators. So I'll write the final answer over here. So I get y equals 1/5 x and plus 22/5. Okay, it's not very clean, but it is an answer, also in slope-intercept form. And notice that here, my slope is 1/5, but my b is 22/5. Over here, my slope is -5, and my b is -6. So that shortcut does not work. If I just change this, the b is probably going to change as well. So only make that change when you are dealing with point-slope form here. So now looking at an application here, we have a town's building code states that stairs and ramps must have a handrail and a sketch of the ramp. So this is the ramp down here, and it has a scale inch, 7 inches per grid is 7 inches. So the handrail needs to be at least 35 inches above the ramp. So using this scale, 7 inches per unit, and we need to get 35 inches above. Notice that I don't count 35, I count how many total. Well, if the conversion is 7, that means I'm skip counting 7. So it's going to look like this. Here's 0, there's 7, then there's 14, 21, etc., all the way till we get to 35. I have to count up 5. 1, 2, 3, 4, and here is 35 inches above. 35 inches above. Now, what do you know about a ramp and its handrail? What do you know about them? They're going to be? They're going to be parallel. Excellent. So you could sketch that here just by going down the exact same amount and over the exact same amount. If I count just the units here, just the scale here, I go down 1 unit and write 2 units. Down 1 unit, write 2. So let's go ahead and just plot those out like so. Go down 1, write 2, etc. So this would be my rail in this direction. All right. So that's step number 1. It says, what are the coordinates of this one? And the coordinates of where the rail starts up at the top is going to be at 77 and 0 for the x. So 0, 77. Where the 77 come from, again, remember, each unit is worth 7 inches. Okay, now how would we write that? When you're counting for the slope, you can either count, since the scales are the same, you could count going down 7 and write 14, or you could have said, I'm going down 1 unit and write 2. Turns out they're the same. Why? Because the scale on the x and the scale on the y are the same. So counting the lines or counting by the actual numbers will yield you the same result. So now we substitute in the 77 here. And the slope, since it is parallel, we say negative 1/2 and x minus 0. Now we do need to simplify. So y minus 77 is equal to negative 1/2 x. Now there is one answer, and if you wanted to put it into slope-intercept form, all we'd have to do is add the 77 to both sides to get this here. So both of these are correct answers depending on the context and what it's asking. Since it only says what's the equation line, we could stop here unless it specifically says slope-intercept form.